Hello, my name is Jan and I will show you today how our software product Yanomaly has been used to monitor 55 electrical substations of Fluvius in Belgium. So if we look at the screen behind me, we see a screen of Yanomaly. In particular, we see the geostatus dashboard, which is a way to look at the anomalies over a geographical map and can be found under the dashboard menu as one of the many options you have there to look at the results of Yanomaly. Other menu options are ensembles, that is where we define how to train a particular anomaly detecting model for a particular asset. With filters, we can select which pieces in the data are interesting to train a particular anomaly detecting model. And under the data menu, we specify the data sources, that is where Yanomaly can find the data that it uses to feed the models. With dataset, we select which subset of that data that is found in a data source is interesting to create a particular model. And with data sync, we specify where Yanomaly should send its results to, for example, to an OPC server. So going back to the dashboard, I have opted here to look at the live view, which for the last 3,600 seconds. So we're seeing at the status in the last 1 hour before now. But you see all statuses are unknown, which is normal because we are not reading today live streaming data from the Fluvius substations. Instead, for the hackathon, Fluvius gave us a historical data set of several years ago. So let me select a period of 3 months in 2018, September until end of November, and click on confirm, and then we see an updated status dashboard where now almost all substations have a green color, so everything is perfect, except in Antwerp there is one which has a red dot indicating that there is a critical anomaly, meaning that at least during one moment over that period of 3 months that we have selected, there was a critical issue. So let's click on that, and then we see the details. We see the anomaly score view. On the vertical axis, we see anomaly score between 0 and 1, and on the horizontal axis, we see time, that period of 3 months. Originally, the anomaly score is very low, indicating everything is perfectly normal. Then around end of October, we have a first peak in the anomaly score that goes up to 1, then it drops again, and then towards November 20 and a few days before and after that, we see a very high anomaly score sustained. So let's look at the detail, click on that. The vertical red line appears, and we see anomaly score. Major contribution to that anomaly score for 47% is the temperature in the ground floor. 21% of the anomaly score can be explained by something abnormal in the temperature of the basement, and the remaining 32% roughly is attributed to all the other sensors together. So let's look first at the main contribution to the anomaly score, which is the temperature in the ground floor, by clicking on that link. And now we see the details of that anomaly score as a function of time. So we see two things. In the light blue color, we see the actual temperature, which is low in this period. And this is the vertical line that corresponds with the anomaly that we have selected. So we see here a high discrepancy between the actual temperature and the predicted temperature in the dark blue. So the dark blue is the prediction made by the model of Yanomaly, and it expects a higher temperature than the actual one, and that generates the high anomaly score. So how did Yanomaly come to that conclusion? So if we look back in time, here in this period where everything was still normal and the anomaly score was low, we see that there is a very nice prediction, a very accurate prediction of the actual temperature. The dark blue and the light blue are very close to one another, meaning the anomaly is very good at predicting what the temperature will be. And we also see these cycles of about 24 hours. This is the normal day-night cycle. It's just colder during the nighttime than during the daytime. Then here in this period, we see flattening of the temperature. That's because the heating is functioning. And when it gets colder than 19 degrees, heating turns on. But then here, towards end of October, we see that the temperature drops further and then gets up again and then again lower, indicating that probably there is some problem with the heating. So let's analyze that in more detail by selecting the zoom function and then selecting this piece of data to look in more detail. So here, at the beginning, we see this very quick up and down, which is not a 24-hour cycle, but this is the heating cycle. So when the temperature drops below 19 degrees, heating turns on, and when it's warmer again, it turns off again. And this is an on-off control, so it turns on, off, and so on. But then here, around this time, heating must have failed because the temperature is dropping. We no longer see this on-off cycle. And then temperature rises again, but that's probably just because the outside temperature is getting warmer. And then towards the end of November, we see that the temperature drops even further, simply because it's colder and the heating is still malfunctioning. So that's what we see here. So in conclusion, we believe that this shows that Yanomaly can detect that there is something abnormal with a sensor reading or with equipment in electrical substations. And I thank you for your attention.